Pairs in the lambda calculus, how can they represent them? So, let's go in our beautiful calculator. What do they have? How we represent pair? So actually pair, it must encode two things. And also it must provide the ability to somehow access to these two things. So, they represent pair as a lambda, which takes some first element of the pair, second element of the pair, and also we want to have some accessor function f. Okay, and how we write this body? I say that I just apply f to a and b. And that's all. Actually, this thing gives me the ability to construct the pair and ability to have the access to this pair. So I defined it like let pair, I think like this. And we have it. Okay, now what we can do? We can define accessor function. So let's define the first function, which actually this function will be here in the position of this f. And what it takes? It takes two elements, a and b, and return to us the first element. And in the same way, they define the second function, which takes two elements, but now produce the second element. Okay, now we can construct the pair, for example, of x and y, and then I construct it. I can access it. For example, if I take the first element, we can see that now I receive the first element. If I take the second element, I have the second element. And of course I can just construct a pair itself in the form of this lambda expression, where this is the higher order function which takes some function f, which can access to this x and y internally. And actually the type of this function defined to each type of the term, this lambda expression will be reduced to the first element or to the second element.